Hey everyone, today we're going to be doing a video on graphing a sine function, and we're going to be looking at this specific function to y is equal to 2 sine of bracket 2x minus pi minus 1, okay? So we're going to look at the details of it, and then we're going to kind of graph it based off of those details to make it a bit more understandable and easier to digest, okay? So first things first, notice that the coefficient of x is not factored out. Okay, that's going to be a problem when we're looking at our horizontal shift. And so the first step is going to be to factor that 2 out. And so I'm going to rewrite this function as y is equal to 2 sine of bracket 2 bracket x minus, and if we're factoring the 2 out of the x and of the pi, we have to write it as x minus pi over 2. Okay, and then at minus 1 at the end. Okay, so now to look at the details of it. In the typical transformational form that you're used to seeing, the 2 acts as our amplitude, our horizontal stretch, as you might have heard it called. That tells us how far up and how far down we're going to go from the midline. Speaking of midline, this is going to be our midline at y is equal to -1. So that'll be our sinusoidal axis. Next, we'll have our horizontal shift, and then we'll have our horizontal stretch, which you might call ST. Okay, so what I like to do is I like to first pop the midline onto the graph so I know where my sinusoidal axis is going to be, and I like to draw a dotted line. Tends to make things easier. Next, I like to start at my horizontal shift, because that kind of acts as our starting point, okay? So since it's x minus pi over 2, we're going to go forward by pi over 2 units in the positive direction. And so let's maybe make that around here, pi over 2, something like that. And now we're going to look at the period. So remember that our period can be found always by 2 pi over b, b being the coefficient factored out in front here. And so if our b has a value of 2, our period is going to be 2 pi over 2. And you see that the 2's nicely cancel out, and so our period is going to be pi, okay? Now, from here, we can start putting hash marks on our graph because we know that's where the important points are going to be. Now, you'll also notice that this is a positive sine function, okay? Now, there are some general guidelines that we can use for positive sine functions. We know that it starts always at the midline, okay? Always starts on the midline. And a positive sine function always goes up first. So it's going to hit its maximum before it comes down and hit its minimum, okay? And then goes up first, okay? So with these details in mind, let's go ahead and start our journey at our horizontal shift. So we're going to start at the midline, right on pi over 2. Okay, so this will act as the start of our journey, and you can imagine the coordinates of that point would be pi over 2, comma, -1, okay? Now we know that our period is going to be 1 pi. So our journey for the first cycle is going to end at pi units later on down the road. So if we want to know where we're going to end our first cycle, it'll be at pi over 2 plus pi. And if you want to add fractions, hopefully adding fractions is something you're comfortable with. We're going to end at, we can treat pi as 2 pi over 2, have a common denominator, and so pi plus 2 pi brings us to 3 pi over 2, okay? So we can pop that onto our graph somewhere around here, 3 pi over 2. Okay. And now, what I like to do for any kind of sine function is remember that it's always symmetrical, and it starts at the midline. It also ends at the midline, right? Because we're going to start another sine cycle afterwards, so it has to begin the next cycle on the midline. And in the very middle, it's also on the midline. Okay. And so then we can start putting additional hash marks to kind of structure our graph. Okay, so we know the middle between pi over 2 and 3 pi over 2 is 2 pi over 2, or simply pi, so that'll be around here. And then sine functions are beautifully symmetrical. And so the maximum that it'll hit around here will be right between pi over 2 and pi. And hopefully you're comfortable enough with fractions to kind of be able to think these things through. If not, I really encourage you guys to get to take a bit of time to really get used to adding and subtracting fractions. It'll save you a lot of time down the road, and it'll really help you make those connections that allow you to solve more complicated problems with these ideas, okay? So the middle of pi over 2 and 3 pi, the middle of pi over 2 and pi will take us to 3 pi over 4, right? Much like the middle between 1/2 and 1 is 3 over 4. We just add a pi in, okay? And likewise, the middle of 1 pi and 3 pi over 2 is gonna be 5 pi over 4, okay? And so we can pop those hash marks onto the graph. This will be our maximum, and this will be our minimum. So 3 pi over 4 and 5 pi over 4, okay? Now, our amplitude of 2 tells us that we need to go up 2 units from the midline for the maximum, and then 2 units down from the midline for the minimum. And so if our midline is at -1, up 2 units takes us up to +1, and likewise, down 2 units takes us down to -3, okay? And so it's a positive sine function, so we go up first. So we're gonna go up to our maximum right here, then we'll go down back to the midline, and we'll hit our minimum at 5 pi over 4. And then you can start to see the shape kind of coming out of the graph. So we can trace a curve through it, something that roughly looks like a sine function. And there we have our first cycle of our sine function, okay? From then on, you could do several cycles worth if that's something that you're so inclined to do. We know that each period is going to be pi units, and so if we add pi units to 3 pi over 2, we'll get around 5 pi over 2, we know here, so then we can start plotting points again, here, here, our maximum, and our minimum, and then we could travel through another cycle's worth of this sine function, and we would go on forever and ever. There are no restrictions on the domain anywhere stated, and so in theory we could go on forever to the right and to the left. If you want to move back one cycle to get into the negatives, we could subtract pi units from pi over 2, and pi over 2 minus pi is going to take us to negative pi over 2, negative pi over 2, like so. And now we're working backwards, so we're going to go down first, and we're going to be back on the midline in the middle, we'll be back on the midline at the end, we're going to hit our minimum down here, and our maximum around here, so that'll take us down here, back up, and so on and so forth. And so we can start seeing the general sine function coming on the graph. You see the midpoint here at 0. The minimum would be at the middle of 0, and pi over 2 is pi over 4, and symmetrical argument brings us to negative pi over 4 on the left side. And so hopefully you're starting to kind of see a pattern of how we can break down the sine function into cycles, right? If we want to look at one full sine cycle, half of it is midline to midline. The first quarter is midline up to the maximum, then maximum down back to the midline, midline down to the minimum, minimum back up to the midline. They're all in quarters of the cycle, right? And all functions behave, all sine functions behave this way. And so as you get more and more practice, you'll start to see these patterns kind of come out, and hopefully you'll get more efficient at solving these kinds of problems. Again, adding and subtracting fractions, I do encourage you guys to take the time to really get comfortable doing those kinds of things. If not, it's going to be super time consuming, and if those are the things that hang you up with these kind of questions, it'll be more frustrating than taking the time to become really comfortable doing it would be. And so I encourage you guys to do that. Hopefully this helps. If you guys have any more specific questions, any comment suggestions on maybe something you'd like for me to elaborate on, or if you want to see cos and tan functions, please do comment down below. Any requests for future videos, please comment down below, and thanks for watching.